Hello friends, in today's question, block B starts from rest and slides on a wedge A which can move on a horizontal surface. Neglecting friction, determine the acceleration of the wedge, and second part, the acceleration of the block relative to the wedge. So this is the basic figure that is given. So this is block A, this is block B, and it is, let us suppose it moves to the right as the block slides down. So in this case, we say that suppose block A moves towards the right, okay, it moves to the right, and block B moves as block B slides down. And we also assume that mass of block A is capital M and mass of block B is small m. And its acceleration is given as small a with the suffix a. Now secondly, the movement of block B, okay, block B slides down the inclined plane, slides down the inclined plane with the acceleration relative to the wedge. Inclined plane with the acceleration relative to wedge, which is nothing but block A. This is given as ABA, and it's directly along the inclined plane ABA. So we can say that this acceleration of block B with respect to wedge can be written as acceleration of block B with respect to ground minus acceleration of block A with respect to ground. Now we are going to find out the acceleration of block A in as x component as well as a y component. Okay. So for that, what we do, we define the our axis as, let us suppose along this inclined plane we are going to have x axis and here it is y axis. So if we define for block B, we can draw as per this axis. Block B will be moving downward with the acceleration of BA, and it will be also having the acceleration of, that is of block A in this direction, and let us extend here. So we can divide this into two components. So one component, it will be coming as a sine of theta. This is, let us put theta angle, and this will be coming as, in this case let us say this is equal to capital A. It will be much more easier to solve this, removing all the subscripts, and this we can write this as a cos of theta. So in this case we suppose, we can say suppose expression of A is now represented by capital A, and this relative expression of A BA is represented by only AB, or rather you can say small a and capital A. So based on this we can say that the x component of the acceleration AB, okay, you see that x component of acceleration for block B will be equal to, okay, this is moving in with A in downward direction, and so net will be A minus A cos of theta. Similarly, we can find out the y component. We can say y component of acceleration for block B, which will be equal to A sin theta. Next, we find out, draw the free body diagram for block A as well as block B, and then we find out there all the resultant forces by using the Fx as well as Fy. First of all, let's draw it for wedge A or block A. So we have said that its mass is capital M, so there will be mg, the downward direction, and it is on the surface like this. There is one normal because of B in this direction, N1, and this N1 will be having two components. This will be our, let's be theta, this will be N1 sine of theta, and this will be our N1 cos of theta, and we also have acceleration A in this direction, and because of this surface it is going to have a normal in the upward direction. Okay, let us call it as N2. So based on this we can find out for block A, or rather I can say for wedge A. For wedge A, we get all the summation of forces in x direction. Okay, we can say summation of algebraic sum of f of x will be giving us n sin theta, and there is only acceleration A also in x direction, so we have n1 sine of theta will be equal to capital M A. And from here we can find out N1. So we can see that N1 is equal to capital M A sine of theta. Okay, let us call this equation number 1. And next is in y direction. Summation of f of y. This will be giving us in y direction we have n2 in upward. So we have n2, and then we have mg in downward direction, that is capital Mg, and also we have n1 cos theta in the downward direction. Okay, so we have n1 cos of theta in downward direction, this is equal to 0. And let us call this as this equation as equation number 2. Now we write for block B, we get, okay, let us draw the free body diagram for the block B. So we have said its mass is mg, small m, so we have mg, and we can divide it into components. So this will be over theta, so we have mg cos of theta, and this will be mg sine of theta, and there will be normal n1 in this direction, n1, and also we have acceleration a in the downward direction. So for block B, summation of forces in x direction, it is equal to mg sine theta is equal to ma. Okay, or we can say in x direction, max. Okay, so we already know acceleration of block B in x direction. Okay, we have that ax, but acceleration in x direction is given as, we found it already, a minus a cos of theta. So we put it here, we get mg sine theta is equal to m a minus a cos of theta, and let us call this as equation number 3. And we have in y direction now summation. In y direction we are going to have n1, mg cos theta minus n1 is equal to m a of y, but we know that a of y, we already found out, is given as a sine of theta, a sine of theta. So we substitute the value, we get mg cos of theta minus n1 is equal to m a sine of theta. Let us call this equation number 4. So we already know value of n1, that is from equation 1, and we put here in equation 4. Okay, so using equation 1 in equation 4, we get mg cos of theta minus ma sin of theta is equal to ma sin of theta. So we can further solve it. We are going to get this as mg cos of theta is equal to ma sin of theta plus capital Ma sin of theta. We take a as common and sin theta as LCM, so we can set that a, this will be m sin square theta plus capital M divided by sin theta. From here we can find out value of a. So we can say that a will be equal to mg cos theta multiplied by sin theta and divided by m sin square theta plus capital M. So this is the acceleration for wedge. And secondly, we are going to use equation 3. Okay. So we can see that from equation 3, we get, okay, so equation 3 was mg sin theta, equation 3 was mg sin theta is equal to ma minus ma cos of theta. Okay. From here we can find out ma is equal to mg sin of theta plus ma cos of theta, and we already know value of capital A, and from here we can clearly cancel out small m, and we know the value of capital A. We can say that A is equal to g sin of theta plus capital A was our mg cos theta sin theta, so multiply this will be equal to cos square theta sin theta divided by m sin square theta plus capital M. So we can further solve it, taking g sin theta is common, and taking this as LCM we get m sin square theta plus, and g sin theta we get this m cos square theta divided by m sin square theta plus capital M. And we can take m as common, so this will be sin square theta and cos square theta, which is equal to 1. So we can say that a will be equal to mg sin of theta, oh sorry, I made a mistake, this one term is missing here, that is capital M, okay, and plus capital M. Let me do it again. We can write this is equal to, taking g sine of theta is common, we get m sine square theta plus capital M plus m cos square of theta and divided by m sine square theta plus capital M. So we can write this as, combining these two terms, this will be m, so we get m plus capital M g sine theta divided by m sine square theta plus capital M, and this will be expression A. Okay, so this completes our question. Thank you.